Good morning, dear students. Today we are going to discuss about the wave motion. Firstly, we know that about the waves. The waves is the disturbance or oscillation that travel through space-time is accompanied by transfer of energy is known as wave. And the wave motion is the transfer of energy and momentum from one point of the medium to another point of the medium without actual transfer of matter between two points. The wave motion are classified according to the medium of propagation, dimension in which a wave propagate energy, and the energy transfer. Here we have the representation of the classification of waves according to medium, propagation of energy, dimension, and vibration. Here we have to classify of wave motion based on the medium. It is divided in two types: mechanical waves and non-mechanical waves. Mechanical waves require the medium and non-mechanical waves does not require the medium. The mechanical waves are classified in two types based on vibration of particles on the medium and based on energy transfer. On the basis of vibration of particles of medium, it is also classified in two types of waves: transfer waves and longitudinal waves. And on the basis of energy transfer, it is classified in two types of waves: standing waves and progressive waves. Here we number of dimension in which a wave can propagate energy is one dimensional waves, two dimensional waves, and the three dimensional waves. One dimensional waves like example of waves produced in a stretched string, and two dimensional like a ripples on waters, and three dimensional waves example of the propagation of light and sound waves. Based on the transfer of energy, we can classify the waves as standing waves and progressive waves. The mechanical waves needs a medium in order to propagate itself. Sound waves, waves is a slinky, and water waves are all example of this. There are following properties of mediums for mechanical waves propagate. First is the medium must possess inertia or mass so that particles can store mechanical energy. And second one is the medium must possess elasticity and the minimum frictional force between the particles of the medium. And non-mechanical waves do not require the medium in direction. These are transfer in nature. Example, electromagnetic waves and matter waves. And now the question is arises, what is the transfer waves? So transfer waves are waves in which the direction of the vibration of particles of medium is perpendicular to the direction of propagation of the waves is called transfer waves. Like example, water waves and the light waves. And the longitudinal waves has the movement of the particles in the medium in the same dimension as the direction of momentum of the waves. For example, sound waves, P-type, earthquake waves, and compression of waves. Here we have the representation of the types of waves, the transfer waves in which the particles of the medium vibrate up and down to the direction in which the wave is moving. है ना? Here we have to shown that the crust and troughs has met and the longitudinal waves which the particles of the medium vibrate back and forth in the direction in which the wave is moving. For example, the waves which travels along the spring when it is pushed and pulled are longitudinal waves. Thank you.